Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Alkene A reacts with 3 moles of H2 to give 1 isopropyl 4-methylcyclohexane. This means alkene A has 3 degrees of unsaturation. 3C is equal to C double bonds. The product is a cyclohexane with an isopropyl group at C1 and a methyl group at C4, so the carbon skeleton of A must be the same as 1 isopropyl 4-methylcyclohexane but with 3 double bonds. Moving on to the next step. Ozonolysis, reductive workup, cleaves each C is equal to C double bond to give carbonyl compounds. The 3 products obtained are HCHO, formaldehyde comes from A is equal to CH2 terminal group. OHC, CH2, CH3, a 1,2-diketonealdehyde fragment suggesting cleavage of 2 adjacent double bonds on a chain. CH3, CH2, CHO, a ketoaldehyde fragment. Moving on to the next step. The presence of formaldehyde indicates A is equal to CH2, isopropenyl type, terminal double bond. The carbon skeleton must contain a cyclohexane ring with 2 additional double bonds in the ring, making it a cyclohexadiene, plus 1 exocyclic double bond, is equal to CH2 on the isopropyl-derived carbon, totaling 3 double bonds. Option B shows a non-aromatic cyclohexadiene ring, 1,3-cyclohexadiene system bearing an isopropenyl group is equal to CH2 and a methyl group at the para position. This structure has 1 exocyclic C is equal to C, D is equal to CH2, giving HCHO on ozonolysis, and 2 endocyclic C is equal to C bonds in the 1,3-diene system of the ring. And for the final step, with the 1,3-cyclohexadiene bearing isopropenyl at C1 and methyl at C4, ozonolysis of all 3 double bonds would fragment the ring and side chain. D is equal to CH2 gives HCHO. The ring diene portion, when cleaved at both double bonds, gives a linear fragment OHC CH2 CH3 from one end and CH3 CH2 CHO from the other end, consistent with the products shown. A is aromatic, benzene ring, which would require more than 3 moles H2 for full reduction, and aromatic rings resist ozonolysis under standard conditions, also the product would be different. C has an isopropylidene, is equal to CMe2, exocyclic double bond, which would give acetone not formaldehyde. D has only 1 ring double bond plus 1 exocyclic, totaling only 2 double bonds, inconsistent with 3 moles H2 consumption. Therefore, the correct answer is B. Therefore, the correct answer is option B.